Okay, so guys, take a look at 2.4 in your book, and it asks you to consider the words bike and book and the number of ways that you can arrange it, right? So if you take a look here, we've listed all the different combinations you can do with those 4 letters. And you can see that there are 4 times 6, right? How can we do this using P notation? It's really easy. It's 4p4, or you can write it as 4 factorial. So 4 times 3 times 2, 24, right? 24 possible words. Now, if you take a look at book is different because you've got 2 identical letters. You've got 2 O's, right? So you've got fewer. You've got 12 different combinations, right? So the way that we can calculate this using factorial notation, we recognize that we can, if they're all different, if they're all unique letters, we have 4 factorial, right? And what we can do is we can use our denominator to eliminate those combinations, eliminate those permutations that are identical. There are 2 identical O's, so we can put that over 2 factorial. And if you evaluate that, you would find that you would get 24 divided by 2 equals 12. Okay. So we're eliminating those 2 permutations that are identical. And actually there are in total 12. Half of them will be identical. So whenever we have objects that are identical, we might have, in a problem like the book word, the word book, we had 2 identical O's. But maybe you have a few different objects that are identical. You can eliminate those permutations by putting the factorials in the bottom. So in this case here, we would find our total n factorial, and then for each identical object, you can put perhaps 2 factorial or 3 factorial. Yeah. Let's take a look at an example. So in example 1, this is kind of just practice of what we learned a couple of days ago. So why don't you go ahead and evaluate those on your own. Mm-hmm. Make sure you get the brackets right. Okay, so what did you guys get for A? 7 factorial over 3 times 2 factorial. 420? Okay, so 420. Of course, you can simplify this. Yeah, you could. So you could, as you can see, you can cancel out these 3 factorials, and that's how you get 7 times 6 times 5 times 5 times 4, and you would get 420. So the exact same answer. For B, what did you guys get? 5,040. Excuse me. So in these examples, if you calculated 8 factorial, it would be a pretty big number. And then because we're dividing by these 2 factorials, we're reducing the number of possibilities, the number of possible outcomes. Like, for example, yesterday, Mr. Ashton showed you 3 different markers and talked about the number of ways that you can arrange them, right? So they each have their own position. And do you remember how many ways can you arrange 3 different markers? 6 different ways, right? What if 2 of them are identical? So this time we have 2 yellow markers. How many ways can we arrange them? I hear 4, I hear 3, 6. Okay, that's interesting. Andrew said divide it by 2. Yeah, there's two yellow ones, right? 2 ways. So we hear 2, 3, 4, and 6. Okay, watch this, guys. Here's one. We have red, yellow, yellow. Okay, I'll read it from your perspective, okay? Yellow, yellow, red. We have yellow, red, yellow. And we have red, yellow, yellow. Okay? And why is that? We have 3 because this arrangement, now watch what I'm doing here. This arrangement is the same as this arrangement, right? I flipped the 2 yellow markers around, but it's the same arrangement, okay? So when we divide by 2, right, we're dividing by 2 factorial actually. We're dividing by 2 factorial. We're eliminating the arrangements that are identical, like this one and this one, or this one and this one, right? And this one, and then if we switch those yellow guys around, right? Does that make sense? So if we had 3 identical objects, right? Then it would be 3 factorial. Yeah, because there would be 6 different ways that you could arrange those 3 identical objects. Sorry? You don't want to do that? What? No. If we, you're right. If we were just arranging 3 identical markers, and I don't have another yellow one, I do have three kind of blue ones. You're right. There's just one way of arranging those. Just pretend this is the same shade, okay? There's just ever one way of arranging those. But now if we introduce a yellow one, so we have 3 identical blue ones and 1 yellow one, how many different ways are there of arranging that? Yeah, 4. I heard it. 1, 2, 3, and 4, right? And the way that we could work that out, we have 4 total objects, so 4 factorial, and then we have 3 identical objects, 3 factorial. And of course, if you work that out, of course, that's 4 times 3 factorial over 3 factorial. You can cancel it out, and it equals 4, right? So just confirmation that that works. Let's go on to, are there any questions so far? Let's go on to example 2. I've seen this question before. You'll probably see something like this on a diploma. In the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags Each flag has a prayer written on it, and each one is a different color to symbolize the different elements. So we've got green, yellow, white, blue, and red, 5 different types. How many different arrangements of the same prayer can you make using these 9 flags? 1 green, 1 yellow, 2 white, 3 blue, and 2 red. So we're going to start this off. We have 9 flags. We have 9 flags. So we're going to start with 9 factorial, right? But there are things that we're eliminating because there are repeats. There are identical objects. There's only 1 green, so I'm just going to write this here. You don't have to write that. I'm writing 1 factorial, which is, of course, 1. That's for green. I'm going to write 1 factorial for yellow. For white, what are we going to write? 2 what? 2 factorial, yeah. 3 factorial for blue, and 2 factorial for red. And does anyone mind calculating that, please? $24, so 24 on the bottom, okay. Good. 150 or 120. Okay, 15,120. So there are a lot of different different arrangements. Now, if you find just 9 factorial, you're going to get 362,000 about, right? So you're eliminating a lot of different permutations because they end up being identical. Does that make sense? Yeah. Good. Example 3. What do you think we're going to do? Be Canadian and answer this true-born Canadian question. So how many ways can the letters of the word Canada be arranged if the first letter must be N and the last letter must be C? Okay, so right off the bat, we know that we have 6 letters, but we're being told that the first letter must be N and the last letter must be C. So I'm just gonna write this out like this. 1, 2, 3, 4, 5, 6. We know that the first letter must be C, so how many choices do we have there? Just 1. And the last letter must be C, so that must be 1 as well, right? So we know that we don't have choices here. What we're left with is these 4, right? We have 4 choices. Now we're going to approach this part. We're going to approach this part like we have been already. So we have 4 factorial on the top, and what are we going to put in the bottom? Our letters remaining are A, D, and A. So what are we going to put in the bottom? 3 factorial. Good. And this is exactly what we worked out over here. So there are 4 different ways of arranging the letters. If we're going off of those kind of restrictions, the first letter must be N, and the last letter must be C. Okay. And does anyone have any questions about that? Is that clear to everyone? Yeah? Okay. Let's move on to example 4. I'm not sure why there's a ballerina there. Nope, it doesn't say anything about dancing. That must be Julie. Can I move Julie out of the way? She's stuck there. Okay. Oh, I see. Oh, I put a couple marks there. Oh, goodbye, Julie. This must be her home, I guess. And this is, isn't it home and school? House and school. Okay, so this is a school, and this is the house. Okay, so if you, I'm going to move the, oh, come on. I'm going to move these out of the way too. And I'll just move that line down there. So if she is starting here, if Julie is starting here, how many different routes can she take to get to this point here? How many different routes can she take to get to this point? If she can only move south and east, right? She can only move south and east. And I heard it there, she can take two different routes, going this way. Yes, she can only move south or east. In other words, she can't like go this way, then back, then this way, or she can't go like that, the long way around. It just kind of means she wants to take the shortest route there, right? So she only travels either south or east. How many different ways can she get to this point here? From her house. Sorry, Dean? I hear 2, I hear 3, so she can go this way, right? And she can go this way, or she can go this way, right? So she has 3 possible routes that she can take. 1, 2, 3. Okay? Now, how many points can she take to get to this location here? Okay, it's kind of the same as this one here. So she can take 3 again, right? 1, 2, 3. Okay? So I'm just going to erase this for now. And we said that she could take 3 ways to get there and 3 ways to get there, 2 ways to get there. What do you think about this one? I'm hearing 4. I'm hearing 6. So she can go from here and then one more road that way, or she can go from here and take one more road that way. So there's these 3 possible options. She can start from there and go. And there's these 3 possible options, and she can go from there. So we add those, so she can do or. She can do that way or this way. And there's 6 possible ways to go there. So what you can do with this question, you can think, how many possible ways to go here? 1, right? Just like that. Same with this one. You can just go 1. Because you can't kind of go the long way around, right? And what you can end up doing with a question like this, I'm going to show you another method after this, is you can add up these 2 to get this, right? Or to get this, you can add up this. 1 plus 2 is 3. So what would go here? 4. What would go here? And 6, right? So what would go here? And what would go here? This is a bit tricky now. So remember, we're adding up. She can come from either this direction or this direction. Right, so we would put 10 here. How about here? Yeah. How about here? Good. 21. Oh, sorry, 20. 35. And finally at the end, 56. And I don't think we did any of our adding wrong, but this looks a little suspicious, doesn't it? No, I think that's fine. 56. Okay? So 56 different ways. And this is always an option. You can do this kind of question like this. It's kind of like brute force. This is one way you can answer this question. I'm going to show you one more way, and then that's it for examples. So there's another way of doing this. You have to think she can only either travel south or east, right? So you can think about giving Julie directions. You can think about giving Julie directions. And let's say she's just going to go like this. Let's say I'm trying to give Julie directions. I want it to go this way. I'm going to tell Julie, go south. This is kind of a stupid way to tell Julie. I'm going to tell Julie, go south, 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 and then go east, 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 east. And Julie would say, okay, that's kind of I don't know why you told me directions like that, but I understand what you mean. So I told her, go south 3 times, and then go east 5 times, right? So I'm giving her how many total directions? Good. I'm giving her 8 total directions. Okay. I can also tell her, go east, east, south, 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 east, 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 right? So again, I'm giving her 8 total directions. And we're going to write that as 8 factorial, right? But how many identical directions are there? So there's 2 possibilities. I'm telling her to either go south or east, right? I'm telling her to either go south or east. And how many times do I say south? No matter what, I'm going to say south 3 times, right? No matter what, I'm going to say south 3 times. So bear with me just a second. And no matter what, how many times am I going to say east? 5 times, right? What do you get if you plug that in? Hopefully. You do get 56, right? So this is another way of doing a question like this. And I want you to just take 2 minutes to think, how is this question almost identical to the question before it? So how are example 3 and example 4 almost identical? Let's take just a minute to think about that, and then we'll move on. Okay, are there any ideas? How are example 3 and example 4 almost identical? Hey guys, we're almost done, okay? Another 2 minutes and then you guys can work on homework. But can you tell me, how are example 3 and example 4 almost identical?
Because Canada crosses the same distance, and then if you can only rearrange 4 letters out of Canada, then it's the same going down. I don't know.
Okay. So it does have to do with like arranging the letters. It does have to do with arranging the letters. Sorry? Okay, that's something else that's interesting. They both have to start in a specific place. Okay? Let me tell you what I think, okay? If you take a look up here, we have this series of letters here, okay? It's kind of like a word. It's kind of like a word that doesn't really make any sense, right? S, 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 E, 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 E. What do you think that means? Good, okay? So I'm using just the first letter to say south, 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 east, 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 right? And this question is basically asking you, how many, these are my directions for Julie. How many different ways can I rearrange those directions? In other words, how many different ways can I rearrange these letters, right? So just like how we were rearranging the letters in Canada, and we had some letters that are identical. In this example, we're rearranging the letters of the word see and finding the total possible rearrangements, right? And this ends up being the same thing. 8. That doesn't make any sense? Okay. 8 factorial. 8 factorial over 3 factorial times 5 factorial. So do you kind of see the connection I'm making here? So I would encourage you when you have some problems that you feel like, how am I supposed to do this? Try to think of a few different ways. Because how many different ways did we solve this problem? Sorry? Okay, yeah, there are 56 ways to get there, but how many different ways did we solve it? We solved it 3 different ways, right?